Artificial intelligence is evolving rapidly, surpassing human benchmarks in cognitive tasks. But one company, Prime Intellect, is focusing on a unique challenge: preventing AI misuse. Not just the sci-fi scenario of machines taking over, but the realistic threat of AI empowering harmful actors to create deadly pandemics or bioweapons. Here's why this matters.
Every drop of wastewater carries a complex signature of life. Trillions of DNA and RNA fragments that tell the story of human health at a societal scale. But reading this story has remained beyond our reach.
A straightforward extrapolation of today's systems to those we expect to see in 2 to 3 years suggests a substantial risk that AI systems will be able to fill in all the missing pieces, enabling many more actors to carry out large-scale biological attacks.
As biotechnology advances exponentially, a new frontier emerges, detecting biological threats before they turn into pandemics.
We believe they're an important step forward in a race to the top on safety. We hope we can inspire other researchers and companies to do even better.
Enter Metagene-1, the metagenomic foundation model. Trained on over 1.5 trillion DNA and RNA base pairs from wastewater samples, Metagene is powered by a 7 billion parameter transformer architecture, capable of analyzing entire microbiomes at a societal scale. It identifies subtle genomic patterns, serving as an early warning system for emerging pathogens. This helps enable a planetary-scale early pathogen warning system to prevent the next pandemic. Metagene excels in detecting anomalies, useful for monitoring novel biological threats. Developed collaboratively by USC, Prime Intellect, and the Nucleic Acid Observatory, it represents a step toward helping safeguard humanity in the age of exponential biology. And we're open sourcing it. Together, we can accelerate scientific AI to create a safer and healthier future.
Prime Intellect has developed a powerful AI called Metagene-1. It works by analyzing wastewater samples containing genetic material from viruses, bacteria, and unknown organisms. Using deep sequencing, these genetic samples are processed into readable DNA sequences. These sequences are then translated into data the AI can understand. With 7 billion parameters, Metagene-1 identifies dangerous pathogens, detects genetic anomalies, and helps predict health threats, essentially acting as an early warning system for pandemics. Metagene-1 is currently the best-in-class AI for pathogen detection, outperforming all existing benchmarks. While most AI development today prioritizes flashy language models, technology like Metagene-1 is critical for proactively protecting humanity. It's essential to focus on such preventative measures now, rather than later when threats become real.
I testified in the Senate that, we might have serious bio risks within 2 to 3 years. That was about a year ago. Things have proceeded apace. So we have this thing where it's like it's surprisingly hard to address these risks because they're not here today. They don't exist. They're like ghosts, but they're coming at us so fast because the models are improving so fast.
AI's rapid advancements bring serious biorisks that could appear within just a few years. OpenAI itself acknowledges that advanced models, like their O1 series, can unintentionally aid in bioweapon creation. Though these models primarily help experts, there's concern they might eventually simplify bioweapon creation for others, especially if protective measures aren't robust enough. Research by MIT in 2023 highlighted how large language models LLMs could unintentionally guide non-experts toward creating biological threats. In 1 hour, students using these AI tools identified dangerous pathogens, synthesis methods, and even recommended labs with weaker security screening. This shows how quickly AI could democratize access to harmful biotechnology. The MIT study concludes that future advanced AI could significantly lower barriers for creating pandemic-level threats, even for those without specialized lab skills. Therefore, it's critical to implement strong safeguards, like pre-release evaluations of AI models, safer training datasets, and strict DNA synthesis screening. However, a separate 2024 study found current AI models aren't yet fully capable of effectively planning large-scale biological attacks. While reassuring for now, experts warn the gap between current capabilities and what's needed for serious misuse is shrinking quickly. As AI progresses, future models may require restricted access or specialized clearances to prevent misuse. Staying vigilant and proactive about AI safety will be essential in the coming years.